Hi, everyone. I'm Sarah Larson from the Multiplicity Lab Group at Northwestern University. Today, we're going to explore one type of look, think, talk activity where the question you ask of students is what's missing. As a quick reminder, in look, think, talk activities, you first show students an intriguing mathematical image and give them time to look. This can be done on a shared screen, or you can print copies for students. Then you pose a central mathematical question and give students time to think. If students have printed copies, you can invite them to annotate as they think. Students also can use manipulatives as an entry point into the task. And finally, ask students to talk about the question with one another and as a whole group. The goal of these discussions is to elicit and encourage multiple ideas, strategies, connections, and ways of seeing and thinking, all while making room for multiple voices. The question, what's missing, can open up thinking about a range of big mathematical ideas. Some of the most frequent that come up are composing and decomposing shapes, composing and decomposing number, and depending on the image, students might be thinking about relating part and whole. And attending to what's missing always requires attending to structure. Let's look at a few examples. Notice that in the center of this arrangement of pattern blocks, there's a hole, a missing section. Determining what's missing involves mentally decomposing the empty space into pattern block pieces. Students will need to grapple with equivalence here and know that the space could be occupied by multiple arrangements of pieces. This is geometric problem solving, an important part of spatial relations. A student might decompose the space in this way, or this way, or this way. You can imagine there are many possibilities for what students might see. Let's look at another example. When we ask what's missing about an array like this, we're really asking how many squares are missing. Again, students need to figure out how to decompose the empty space into parts, this time into square units arranged in rows and columns. The green squares in this array help students mentally extend the row and column structure to see what's missing. Beyond decomposing space, this is also about seeing that square units, which we use to find area, can be found inside of otherwise blank spaces. In the end, students need to both decompose the space and also recompose the number of units. A student might, for instance, begin by decomposing the space this way. From there, they could begin to recompose the space like this and count the 4 square units that fit in the area, leaving space to recompose the other space into 4 units too, which can position them to add the 2 spaces together and conclude that there are 8 square units missing altogether. You can imagine, again, there are many ways to see this space, and this was just one example. For a completely different take on what's missing, try an image from the real world. Just like with the arrays, in this image, there's a partially hidden row and column structure that students can use to figure out what's missing from the pan of fruit bars. However, depending on your student's experience, the question what's missing can be asking how many pieces are missing, as with the arrays, or it can be asking what portion of the pan is missing, a part and whole fraction question. Students might interpret the question differently, or you might pose the question intentionally to provoke thinking about either whole numbers or fractions. We have dozens of what's missing activities at Multiplicity Lab. To find these, begin looking at the Look, Think, Talk tab. You can use our filter to select the question, what's missing. And if you'd like to narrow your search, you can select a grade level or material, like pattern blocks, arrays, or real-world images to match your goals. We hope you'll try one of these with your students tomorrow.